So let's use the same idea to graph harder rational expressions. So say we have 2x squared plus 7x minus 4 over x squared plus x minus 2. And I want to graph this. I want to find my asymptotes. If I can graph my asymptotes, I can start to get an idea of where this thing should lie. Horizontal asymptotes actually going to be pretty easy. Again, I'm just looking at the largest power of the top and the bottom and just doing a ratio of it. So just dividing the coefficients. So 2 over 1 would just give me a 2. So I have a horizontal asymptote of y equals 2. Okay, vertical asymptote, I need that denominator not to equal 0. So x squared plus x minus 2 equals 0. So x plus 2, x minus 1 equals 0, x equals negative 2 and 1. So I have two vertical asymptotes. I have vertical asymptote at x equals negative 2 and x equals 1, which means my domain, because domain and vertical asymptote very related, my domain would be everything from negative infinity to negative 2, not including negative 2, union negative 2 to 1, not including 1, union 1 to infinity. So everything but the negative 2 and the 1. So let's go ahead and try to graph this. I'll try to graph it down here, I guess, so we can get a little bigger. So I have vertical asymptotes at negative 2 and 1. And I have a horizontal asymptote at 2. So now I kind of need to see what it's doing in every part of this. So what is it doing when it's less than negative 2? What is it doing in between? And what is it doing when it's greater than 1? Again, it can cross the horizontal asymptote kind of in the middle. A horizontal asymptote just means that as it's going to infinity or negative infinity, it's following that line. So I'm going to go ahead and plot a few points and see what it's doing. So I'm going to pick things greater than negative 2, so like negative 3. And let's do negative 5 just so I can get an idea. So negative 3 and negative 5. And I'm going to plot them and I'm going to say, okay, 2 times negative 3 squared plus 7 times negative 3 minus 4 all over negative 3 squared minus 3 minus 2. So I should get negative 3 squared is 9, 18, minus 21 is negative 3, minus 4 is negative 7. 9 minus 3 is 6, minus 2 is 4, so negative 7 over 4. So negative 3, I was still in the negative, I was a little bit below negative 1, so I was right about here. If I sub in negative 5, I'd be doing the same thing. I would get 2 times negative 5 squared plus 7 times negative 5 minus 4 all over negative 5 squared minus 3 minus 2. So 25 on the bottom, 25 minus 3 minus 2 would just be 20. On the top, I should get 25 times 2 is 50. 50 minus 35 would be 15, minus 4 would be 11. So I get a positive number. It's pretty small, but positive number. So I can kind of tell how this should work out then. Should get something like that. Can do that above 1. Can sub in 2, 3, or 4. So let's do that. If I sub in, say, 2, I'll get 2 times 2 squared plus 7 times 2 minus 4 all over 2 squared minus 3 minus 2. So on the top, I would get 4 times 2 is 8, plus 14 would be 22, minus 4 would be 18. On the bottom, I would get 4 minus 3 would be 1, minus 2 would be negative 1. So I would get negative 18, so something way down here. So I can pretty much tell how this is going to go. Should go like that. Now I just got to see what's happening here. What is happening in the middle? And I want to plug in a few points. I'm going to plug in my 0 because it's pretty easy, but I want to plug in a point close to this asymptote, this vertical asymptote, and a point close to this vertical asymptote so I can see what the relation is. So If I plug in 0, shouldn't be that hard. 0 plus 0 minus 4 is negative 4. 0 plus 0 minus 2 is negative 2. So I should get a positive 2. So as I said, we can actually hit the asymptote. I just didn't expect it to do it on the intercept. Weird. Okay, so we can actually hit the asymptote. So we do. I have it right there. So let's plug in stuff closer to this vertical asymptote. So I'm going to plug in negative 1. 2 times negative 1 squared plus 7 times negative 1 minus 4 over negative 1 squared minus 3. Why did I do minus 3 on every single one? That would have been minus 5. That would have been plus 2. Which would have changed all of my answers. Would it have made that big of a difference? This would be 17, so no, not that big of a difference. 4 plus 2 is 6, minus 2 is 4. 18 over 4 would be 9 over 2. So 4.5. So that actually made a huge difference. This is actually wrong because this should be up here. So obviously check your work. Okay, so this would be minus 1, minus 2. So negative 1 squared is 1, times 2 is 2, minus 7 is negative 5, so negative 9. 1 squared is 1, minus 1 would be 0, minus 2 would be negative 2, so 4.5. So somewhere up here. So on this way, it's going like that. Let's see what happens as it's going this way. So I'm going to plug in a negative 1/2. So if I plug in a negative 1/2, I guess I'll do it down here since I'm running out of space. I will get 2 times positive 1/2, 0.5 squared, plus 7 times 0.5 minus 4 over 0.5 squared minus 0.5 minus 2. So I am going to get 0.5 squared is 1/4, so 0.25 times 2 would be 1/2, plus 7.5 would be 3/2 minus 4. So 2 minus 4 would be negative 2. On the bottom, I would get 0.25, so 1/4, well, let's just do 0.25, minus 0.5 minus 2. So I would get negative 0.25 minus 2, negative 2.25, which would be 2 1/4. So negative 2 1/4 would be negative 8, negative 9 over 4. So negative 2 times 4 over 9 be 8 over 9. So I should get 8 over 9. So that would be closer to 1, so it's coming down. So I should get it to look something like that. So my graph should look something like that. So really, it's just plotting a bunch of points. Once you figure out where your asymptotes are, it's plotting a bunch of points and trying to see where it actually lays.